We are in lesson 7.2, entitled Percents and Proportions. We're going to begin here with the reading portion. A percent bar model compares a part to a base. In the model shown, 35 is the base and 14 is a part of the base. The percent bar model shows that 14 is 40% of 35, or equivalently that 14 out of 35 is equivalent to 40 out of 100. So again, looking at the bar model over here, you can see how if you have $35 as your total, that's 100% of what you've got. If you didn't have any money, you'd have 0% of 35. We can break $35 into 5 equal parts, like this. Why 5? It's a convenient number for both 35 and 100. You can see that if you do divide $35 into 5 equal parts, here we would have $7. Here you're looking at the $14. This would be 21. This would be 28. And then this, of course, is 35. On the other side, you can see how that matches up. This would be, the $7 would be 20%. 14 matches up with 40%. Adding on another $7, $21 would match up with 60%. $28 would match up with 80%. And 35 matches up with 100%. So it's just a way for us to see how percent works in relation to a proportion. The next thing that we would read down here is where they're summarizing it algebraically. It says solving percent problems. You could represent A is P percent of B using the proportion A over B equals P over 100, where A is a part. The top number of any fraction is always the part of the base B. There's the whole. And P percent, any percent can be written as a fraction over 100. P over 100 is the percent. So we are using proportions to represent and solve problems regarding percent. So if I look at my note-taking guide now, I see the first thing is the box summarizing exactly the same thing I just read. So I'm going to move on to example 1 in my book, which is about actually using a proportion to find a percent. And the question is, what percent of 7 is 4? We're going to write a proportion using that same format. A over B, A is the part, B is the whole, is equal to P over 100, P is the percent. Now, because it says what percent of 7 is 4, you could change that statement to make more sense to say what part of 7 is 4. So we're looking for something that's a part of 7. 4 is a part of 7, and we want to know what percent that is. So you can see 4 is the part, 7 is the whole. We don't know the percent, but we can figure that out using what we know about proportions. Now be careful, a lot of people will assume that the bigger number is always going to go on the bottom of the fraction. That does not always happen, so you have to think harder than that. We'll talk more about that later. All right, here they're taking that same proportion and they're starting to solve for P by multiplying each side by 100. Why? They're using our inverse operations that we use to solve equations. A proportion is an equation. It has an equal sign in it. And so it can be solved using inverse operations. So because we're trying to isolate P, and P is being divided by 100 in the original proportion or equation, we can solve for P by multiplying both sides of the equation by 100. Now they're not showing us how they got that. Let's take a look. On the right-hand side, I could think of this as 100 over 1 using multiplication of fractions, I can see I've got a 100 on the top and a 100 on the bottom that cancel each other out. Ones all over the place. You can see how p is isolated. On this side, I need to think about 100 over 1 times 4 over 7. I don't see any numbers in the top of the problem that have a common factor with a number at the bottom of the problem, so I'm just going to have to multiply across. I'm going to do that over here. 100 times 4 is 400. 1 times 7 is 7. So to simplify that, I have to divide 400 by 7. And I can use whatever method I like. I'm going to go ahead and use traditional. I know 7 goes into 45 times. 5 times 7 is 35. Subtract, and you get 5. Compare, 5 is less than 7, so bring down 0. 7 goes into 50. Let's see, 7 times, because 7 times 7 is 49. Subtract, and we get 1. So you can see how they got their 57 and 1/7 for a final answer. Now, what does that mean? If p is 57 and 1/7, going back up here, p is that percent. So their final answer, 4 is 57 and 1/7% of 7. Now, there are some checkpoint questions here, which you certainly could try. I'm going to go over to my note-taking guide, however, and see if I can work through example 1. It's just like what I saw in my book, just different numbers. The question is, what percent of 9 is 5? Again, percent can be interpreted as the word part. What part of 9 is 5? So you can hear, like, I'm looking for a part of 9. 9 is the whole, 5 is the part. So here's the original proportion that they've given us to work with. I'm looking for a part of 9, so 9 is the whole, 5 is the part. I don't know the percent, so I'm going to leave that as p. Now they're taking that proportion and they're thinking, how can I solve for p? Since p is being divided by 100, I'm going to multiply each side by 100 to isolate p and solve the equation. So over on this side, 100 over 1 times p over 100. These 100s are going to cancel each other out, leaving p isolated. Over here, 100 over 1 times 5 over 9. Again, looking at the numerators, the top numbers don't have any common factors with any of the bottom numbers. So I'm going to have to multiply across. Again, I'm going to show my work over here so you can see what I'm doing on the right-hand side. Multiplying across, 100 times 5 is 500, and 1 times 9 is 9. So I've got this division I'm going to have to do. 500 divided by 9. I'm going to use the other method, partial quotients. Equally good. I'm going to think about 9 times what is close to 50. 9 times 5 is 45. 9 times 50 would be 450, so that's an option for me. When I subtract, I will get 50. Again, 9 times 5 is 45. Subtracting, I get a remainder of 5, which is less than 9, so I can stop and write a mixed number. Looks like I'm going to get 55 for the whole number and 5/9 for the fraction. So p is equivalent to 55 and 5/9. Going back up here, p is a number over 100. So that means 5 is 55 and 5/9% of 9. That's the end of example 1.